Alright folks, now we're going to move on to the really fun stuff. For those of you who like counting in different base systems, you actually probably already know this. For the rest of us who are pretty much happy with counting in the base 10, some of this information may be new, or maybe a refresher if you've had some of this stuff back in maybe college or in some high school computer classes. We're going to be talking about binary. Binary is simply an on-off numbering scheme where the decimal world is the numbers 0 through 9. Most of us will say 1 through 10. But it's really 0 through 9, and then we start over again when we hit 10. And we start over again when we hit 20, and we start over again when we hit 30. So if you look at the PowerPoint slide here, what I have here is decimal. Yes, I know you know it. But what I want to discuss is some of the basics about why decimal is used the way it is. Many of us have never even given it a thought. So as I list here, we've got 5 fingers on our hands, and we start counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That stuff I know you guys know. But the numbering scheme itself, maybe you haven't noticed. You probably have. But just to make sure, is a repetitive symbol scheme. We've only got 10 symbols. The circular 0, the line for 1, the squiggly symbol for 2, the other squiggly symbol for 3, and all the other squiggly symbols we use. But we only use 10 of them. And then we run out of them. So when we're talking about 10 or 11 or 12 of something, we have to start reusing our squiggly symbols. So that's why I've got the numbers showing up the way that they are. Fairly simple. You guys probably got a grasp on that. Now, let's move on to our next page here. Dun, 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 dun. So, in binary, we're only using 2 symbols. We're using the round 0 and the straight line 1. Those are squiggly symbols. We're using binary because computers have a tough time with something other than binary, counting in decimal, or even hexadecimal, which many of you may know is very common with computers. But that's really a grouping of binary. A while ago, a company called DEC, long time ago actually, came up with a computer that was able to count in the base 10. But it was kind of kludgy because they used different voltages to be 0, to be 1, to be 2, to be 3. And these aren't the voltages, but for example, 1 volt would be 1, 2 volts will be 2. But what happened if the voltage wasn't exactly 1? What if it was slightly over 1? Would that have been 2? Or because it was closer to 1, would it be 1? So the system was basically scrapped, and binary is what's won out. So you have a particular voltage or voltage range, and that can be 1. And less than that voltage range can be 0. The numbers are grouped in bits and bytes and nibbles. For those of you who've heard that term, that will be 4 bits. And the bytes will range from a group of 8 zeros all the way through all the different combinations of a group of 8 ones. I list some other numbering schemes here. Octal, base 8. Decimal, base 10, we know. Hexadecimal, base 16. And hexatrigesmal, which is something I sort of invented. I may not be the only person to have done so, but I did do it on my own. And that's using all the squiggly symbols we know in the numbering scheme and our use of the English lettering scheme. So you can come up with other numbering schemes if you want to. But let's get on to understanding binary. Now, the decimal symbols that I show in the next PowerPoint slide, again, we're familiar with those symbols. We understand those numbers. We know how to add them and subtract them and multiply and divide and maybe a few other things if you're wicked smart. And then we have binary, which only has 2 symbols. And when we need to start reusing them is when we run out of the use of the symbols before. So The number 0 is the same. The number 1 is the same. The number 2, however, is going to look different because we don't have a squiggly symbol for 2. We've only got 2 squiggly symbols, 0 and 1. So the number 2 looks like the decimal 10, but it's not 10. It's the number 2 in the base 2 counting system. Now, what I also decided to do is show you an example of counting in the base 1. But in the base 1, I couldn't figure out what symbol to use. Should I use the circular O, 0? Should I use that linear 1? So I decided to use cats instead. So counting in the base cat, or the base 1, we have the following numbers. 0, there have no cats. 1, there's 1 cat. 2, you have 2 cats. 3, you have 3 cats. So the number of symbols is the amount that we're talking about. Running through all this way, you can look down the pyramid that I have either in the PowerPoint book that I made or the presentation that I have here. And I actually did on the PowerPoint, not in your books, but copy out, print out 255 cats, which would equate to the number 255 in decimal, or the number 1111111. Did I say enough ones? I hope I did. Anyway, if I said 8 ones, that'd be good. Those are all representative of the number 255. Now, we could have some exercises on decimal math if you'd like. So raise your hands. Let me know if there's anyone who wants a couple examples of adding and converting to decimal and or to binary or to cats, and we can do that now.